Well, good afternoon. Actually, it's from and to the cloud. So I'm very glad to present here what has been and what is still a great collaboration between Orange, ActiveEon, and INRIA. So we have been working on the integration of two OW2 projects, ProActive and CLIF, in order to bring some added value. So ProActive is a platform which enables both cloud aggregation of existing resources together with the use of public cloud. And CLIF is a load injection framework which makes it possible to easily deploy application, deploy load onto the applications, and also deploy some tools that will gather the information about what is going on with the system under test. And we've been taking advantage of that to do it, as you can see on the title, in a community manner. And a community manner in that way means that end user of the system can even provide their machines in order to contribute to the platform and also to get to a very distributed platform, which is a very important quality for a test system, because you want to test different latencies and different bandwidth in your system. Okay, so this is what we'll be presenting today. So I will give a short introduction, then Daniel will explain the idea behind Community Cloud, and finally Bruno will explain the architecture of the system and what we achieve and some perspective. Okay, so ProActive make it possible to actually gather physical resources in the company and to use external resources like Windows Azure Cloud Platform, but we are also interfaced with OpenStack instances and with HP Cloud, for instance. And on top of that, we provide scheduling and orchestration. So orchestration in the sense that we have a workflow engine integrated in the platform, which enables to basically manage what we call workload management for a company. And we enable the enactment of workflows. So it's workflows that come after people workflows where you want to deploy actually application in your platform. And actually we can deploy application with both native executable, but also software appliance, virtual system. Okay, so ProActive OW2 projects are a lot of users worldwide, and ActiveEon has some customers. So to refer to this morning keynote talks, it's a free model where we provide the entire system in open source within the OW2 base. And we have customers in IT, in engineering, in finance, in biotech, and also in media and distribution. Okay, so as a perspective, I'd just like to draw a strong point about the need for orchestration and cloud brokering. So we are also part of the Compatible One project, and ProActive make it possible to aggregate things like local resources, OpenStack, and proprietary system like VMware, for instance. So it's also a migration for existing proprietary software to a system which is more open source. And we are actually presenting this kind of integration with GDF Suez at Ministry of Finance in a big project called Unif Cloud, where we are actually aggregating different parts of the system. So as said just in the previous talk, it's very important to have the capacity to mix local resources with public and specific cloud. So in that framework, we have been working to build a community cloud, and Daniel will explain in that framework what is a community cloud.
Thank you, Denis. So I will shortly present you what's a community cloud. Community cloud is actually more or less the good old idea of the grid, and it's still always economically innovative. The basic idea is to make a cloud by using not only large data centers, but also normal, regular, small resources, or my PC, your PC, etc., and to integrate them to an existing cloud. So from a certain point of view, this application may be one of the many use cases of the community clouds. That's why I present you what's a community cloud. A community cloud is defined when the members of a community decide to share their CPU, storage, networks, etc., in order to build a common platform on top of which running cloud services. This cloud platform may be managed by the community itself, or the community may delegate to an external manager, for example, a big operator like Orange. And for telecom operator, this is highly legitimate to make people share their resource, because after all, the telecommunications is a matter of making people communicate and share something. So this is why at Orange Labs we have been working on this subject for 2 or 3 years, and this is not the first use case of a community cloud. We have started 2 or 3 years ago with ActiveEon first. It was on a use case dedicated to video application. This is the normal, the basic community cloud case, where several SMEs in the video sector decide to share their resource. So the community clouds have several technological problems: storage optimization, security, and performance, because the community clouds are subject to resource churn, etc. But this is not the subject today, so I hand over to Bruno to present the rest of the application. Thank you.
Thank you, Daniel, and good evening. So what to do with the community cloud? What about load testing? When you want to test the performance of a system under test here, think about your web application or your DNS cluster or whatever, you need to have big resources. So typically you build a small data center made of servers and network equipment and software to generate traffic, a flow of requests on your system under test, and then you measure response time and resource usages, things like that. And so this is very costly, and not all projects can afford buying such an infrastructure. So, but if you look at any company, there are lots of PCs, tens, hundreds or thousands of PCs, like here at Orange Labs, that do nothing at night or during weekends. So how about building a community cloud and running a load test with it? If we want to do that, first thing we'll do is to take OW2's load testing framework, CLIF, which is a project I'm leading since the very beginning, in the name of Orange. The peculiarities of CLIF is that it provides high-power load injection support. You can imagine tests including hundreds of load injectors and with millions of virtual users. With CLIF, you will be able to deploy load injectors and probes, and to measure response times and resources usage. CLIF is very flexible in that it provides different variety of user interfaces, GUIs and command line, on integration to Eclipse or Jenkins, for example. Also, it's flexible in that it supports many different protocols. The main ones are listed here, but you can also integrate your own protocol, proprietary or new that is not included today, with an Eclipse wizard, so you can integrate your own injector in Java. As a peculiarity also, the architecture of CLIF is based on the OW2's fractal component model. So the distribution aspect is very important in CLIF. It's very critical. So it is based on communication middleware, fractal RMI, which is a reference implementation from OW2. As of current SVN trunk and available binary distribution, this is based on fractal RMI, and it works all right as long as you stay in a single network, I would say, and that you don't have a big deployment. So when it comes to a wide test with many load injectors on probes across several networks, you may encounter reliability troubles and also troubles with routing issues with private network. So we needed something stronger than RMI and more adaptable as a communication middleware. And we use ProActive because, first of all, well, it provides those kind of features. It's an OW2 project. It's a very good communication middleware with a lot of maturity. And, well, also, it has a fractal flavor through the grid component model implementation. And we built, with ActiveEon, we collaborated in order to build this new branch of CLIF based on ProActive. So if we want to build our load test with CLIF on Community Cloud, we'll use ProActive not only for its advanced communication support, but also for the cloud-related features. So here there is the system under test. Here there is our community cloud with all the contributors, so the PCs that are available. On each PC will run a ProActive agent. Those agents will register themselves into the ProActive resourcing node. So this node, the resourcing node, will know which resources are available, because in the community cloud, resources appear and disappear very often. And at the other end of the chain, you have the performance tester. He or she defines a load test with CLIF. It uploads it to a continuous integration server based on Jenkins and the ProActive CLIF plugin. If you don't know what Jenkins is, just think of it just as a web GUI for a CLIF. And then when the tester wants to run a test, it interacts with this GUI, and then a job will be submitted to the ProActive scheduling node, and then the scheduling node will find the right number of resources in order to run the test. So there will be one computer here used for each load injector. So I have to finish now with the perspectives. We are finishing currently an infrastructure to run a friendly user test of ProActive CLIF on Community Cloud in collaboration with ActiveEon. As far as CLIF is concerned, we'll be going further into the integration of ProActive as a main communication middleware for CLIF, as in the SVN trunk. And to do this, we'll collaborate within the Open Cloudware project. And the other perspective is that we want also to integrate, to aggregate various sources of resources, like community resource clouds and also big data center-based clouds. Thank you.